Hello students, in today's video we are going to see the formulas from integration, and in later lectures we are going to see more formulas, and then we will see the MCQs on integration. Before going to the MCQs or the tricks, we must memorize the formulas first, so we must first remember these formulas. So let us see some basic formulas from integration in this video. Let's see first the definition of integration. So it is just the inverse process of differentiation, which can be defined like this: if the derivative of function f of x is equals to g of x, then f of x is called as the antiderivative, or it is called as the indefinite integral, or it is the primitive of g of x. And in this case we write this as integral of g of x dx is equals to f of x plus c. It means that they are the inverse processes. If the derivative of f of x is g of x, then the integral of g of x is nothing but f of x. So in this notation of integral of g of x dx equals to f of x plus c, g of x, that the function which is to be integrated, is called as the integrand, f of x as the integral, or one can say primitive, c as the constant of integration, and this dx denote the reference of integration. Dx denotes the reference of integration. Okay, now let us see the formulas as seen in the definition, that the derivative and integration, or the differentiation and the integration, are the inverse processes of each other. So derivative of kx plus c, then it comes to be k, because the derivative of c is a 0, is k which is constant as it is, and the derivative of x is 1 and the derivative of c is 0. So what do you observe? That the derivative of kx plus c is k simply, and so by using the definition I can say that the integral of k is nothing but kx plus c. The integral of k with reference to x is nothing but kx plus c. So in the same way we can derive the more formulas. So in present lecture we are just going to memorize these formulas. We can derive these formulas using the definition, and already you might have studied this in board pattern. So just remember this, memorize these formulas. The second formula is integral of x raised to n dx equals to x raised to n plus 1 upon n plus 1 plus c, where n is not equals to minus 1. Because if n is equals to minus 1, in that case the denominator on the right side will become 0, and that quantity will not exist, and therefore n should not be equals to minus 1. So what happens if n is minus 1? It means integral of x raised to minus 1, which is given in the third formula, that is integral of 1 by x dx is equals to log of mod x plus c, where x is again non-zero. If x is 0, then the denominator will become 0 and the quantity will not exist, and so x is non-zero. Fourth formula, we know the derivative of cos x is minus sin x, and therefore the derivative of minus cos x is plus sin x, and so we have the fourth formula, integral of sin x dx is equals to minus cos x plus c. The fifth formula is integral of cos x dx is equals to sin x plus c. Okay, let us see formulas. Integral of sec square x dx is tan x plus c, because the derivative of tan x is sec square x. The derivative of tan x is sec square x, and therefore the integral of sec square x is nothing but tan x plus c. The integral of cosec square x dx is equals to minus cot x plus c. Integral of sec x into tan x dx is equals to sec x plus c, because the derivative of sec x is sec x into tan x, and so integral of sec x into tan x is nothing but sec x plus c. Next is the integral of cosec x into cot x dx, which is equals to minus cosec x plus c. The integral of tan x dx is equals to log of mod sec x plus c. This mod is for the existence of log, because we know that the logarithm of negative numbers doesn't exist, and in case of sec x is negative, then log of negative quantity will not exist, and so one should take the mod here. The integral of cot x dx is nothing but log of mod sin x plus c. Okay, let us move further. The integral of sec x dx is equals to, there are the methods for finding these integrals, so we have to just remember these formulas now. Integral of sec x dx is equals to log of mod of sec x plus tan x plus c, or it is also equals to log of tan of pi by 4 plus x by 2 plus c. Okay, next 13, integral of cosec x dx is equals to log of mod of cosec x minus cot x plus the constant c, or it is also equals to log of mod of tan x by 2 plus c. Next is the 14th formula, integral of e raised to x dx is equals to e raised to x plus c. Next is 15th one, integral of a raised to x dx is equals to a raised to x upon log a plus c. Okay, move further. Next is the 16th formula, integral of 1 upon under root 1 minus x square dx, it is equals to minus cos inverse x plus c, or it is also equals to sin inverse x plus c. So remember, integral of 1 upon under root 1 minus x square dx is nothing but sin inverse x plus c, or it is minus cos inverse x plus c. Next is 17th one, integral of 1 upon x under root of x square minus 1 dx is equals to sec inverse x plus c, or it is equals to minus cosec inverse x plus c. All these formulas are obtained using the definition of integral, that the differentiation and the integration are the inverse processes of each other. So you can observe in each case the derivative of the integral is nothing but equal to the integrand. Next is 18th formula, 1 upon 1 plus x square dx is equals to tan inverse x plus c, or it is also equals to minus cot inverse x plus c. 19th one, integral of 1 upon under root a square minus x square is equals to sin inverse of x by a plus c. In some cases one may write minus cos inverse of x by a plus c. Okay, move further. 20th formula, integral of 1 upon under root x square minus a square dx is equals to log of mod of x plus under root of x square minus a square plus c. Then is 21, integral of 1 upon under root x square plus a square dx is equals to log of mod of x plus under root x square plus a square plus c. Then 22nd, integral of 1 upon x square plus a square dx is equals to 1 by a into tan inverse of x by a plus c, or one may write minus 1 by a into cot inverse of x by a plus c. Next is integral of 1 upon x into under root x square minus a square dx is equals to 1 by a into sec inverse of x by a plus c. Okay, move further. 23rd formula is integral of 1 upon x under root x square minus a square is equals to 1 by a into sec inverse of x by a plus c. And if we differentiate the right hand side, we will get the integrand. We will get the integrand with this term. Next is integral of 1 upon x square minus a square dx is equals to 1 by 2a log of mod of x minus a upon x plus a plus the constant of integration c. Next is integral of 1 upon a square minus x square dx equals to 1 by 2a log of mod of a plus x upon a minus x. This is 26th, integral of under root of a square plus x square dx is equals to x by 2 under root a square plus x square plus a square by 2 into log of, it should be mod of x plus under root a square plus x square plus c. Next is integral of under root a square minus x square dx is equals to x by 2 into under root of a square minus x square plus a square by 2 into sin inverse of x by a plus c. Next is 28, integral of under root of x square minus a square dx is equals to x by 2 into under root of x square minus a square minus a square by 2 into log of mod of x plus under root of x square minus a square plus c. Okay, so here are the two reduction formulas. for integrating sine raised to some power of x dx. Integral of sine raised to nx dx is equals to minus cos x into sine raised to n minus 1x upon n plus n minus 1 upon n into integral of sine raised to n minus 2x dx. And last here, integral of cos raised to nx dx is equals to sine x into cos raised to n minus 1x upon n plus n minus 1 upon n into integral of cos raised to n minus 2 of x dx. So here are some formulas. In the next video we will see more formulas, we will see more theorems on integration and methods of integration. So thank you for now. Before going to the next video, you must memorize, you must remember these formulas, then and then only you can understand the more formulas, more theorems, or you can solve the problems, or you can have the tricks also. Thank you.